So here we have example 2, and for example 2, we are only looking at it from the perspective of one acute angle, theta. And we're going to find all 6 trigonometric ratios with respect to the angle theta. Now, I only have 2 sides of this triangle. Some of you might see that we have 6 and 8. 6 and 8 as a pair, as a ratio together, can be simplified to 3 and 4. But this is not a 3, 4, 5 triangle, because the 6 and the 8 would have to be the 2 legs, and then this would be 10. 3, 4, 5, 6, 8, 10 is just a double of a 3, 4, 5. So that means we do need to do the Pythagorean theorem for this example. So if I do the Pythagorean theorem, 6 squared plus x squared is 8 squared. 36 plus x squared equals 64. If we subtract 36 from both sides, we'll get x squared equals what? X squared equals 28. Then we take the square root of each side. The square root of 28 is not wrong for the missing side, but it's not simplified. What numbers multiply to give you 28? Not only what numbers, but what prime numbers? What is the prime factorization of 28? What are the ingredients that make up 28? The purest ingredients are 2 times 2 times 7. So I'm going to go up over here, really taking the square root of 2 times 2 times 7. And the square root, we take out a perfect square. So that makes this side 2 radical 7. Now that we have all 3 sides, we can go ahead and find our answers. What is the ratio for sine? Sine is opposite over hypotenuse. So, SOH. What side is opposite from theta? 2 square root 7. And the hypotenuse is 8. While there's nothing wrong with this answer, we're not finished yet. We should simplify. We should always simplify, and we should also always do one other thing. It was mentioned on the first page of notes. Do you remember what that other thing is? We don't need to do it for this problem, but we do need to do it for other questions on this page. The other thing we need to do is always rationalize our denominator. We will have instances where that happens, just not this one. My final answer will be sine theta equals. Now, if I reduce this, I'm going to reduce a 2 from the top and the bottom, the numerator and denominator. Radical 7 stays as is. That's just how this works. So we end up with the square root of 7 over 4. That's our final answer. Next up, cosine. What's the ratio for cosine? Cosine is adjacent over hypotenuse, or ka in the ka toa. Adjacent, what side is adjacent to theta? And what side is the hypotenuse? What does 6 over 8 reduce to? What's 3/4 as a decimal if the question had choices as decimal representations? 0.75. 3/4 or 3/4 is 75%. However, we can just write, for now, we always try to leave it as a fraction, cosine theta equals 3/4. We'll go back and highlight our answers at the end. You should definitely circle or highlight your answers after you finish a question, especially when there's a lot of writing when it comes to simplifying and rationalizing and things of that nature. What's the ratio for tangent? Tangent's ratio is opposite over adjacent. Which side is opposite of theta? Which side is the adjacent? How does this answer reduce? So our final answer will be tangent of theta equals the square root of 7 over 3. Another thing I would definitely recommend is don't write your fractions slanted on a diagonal. I would definitely say that would not be in your best interest. For the next example, we're looking at cotangent. Cotangent is the reciprocal of which of these functions? None of these are reciprocals. These are our three basic trig functions. These three are all reciprocals, so we can shortcut a little bit in this example because they're all theta, and we already did the three basic, and now we're doing the three reciprocals. Cotangent is the reciprocal of tangent. Cotangent is adjacent over opposite. Now my final answer for tan theta was radical 7 over 3. That means cotangent will be 3 over radical 7. While it's reduced, it's not rationalized. We need to rationalize our denominator. What do I need to multiply on top and bottom by? We need to multiply on top and bottom by radical 7. When you multiply on top and bottom by radical 7, you're really multiplying by what number? You're really multiplying by 1, and that's why we're allowed to do it. Now, make sure you fully execute that multiplication. Don't get lazy after only dealing with the numerator. 3 times the square root of 7 is just 3 square root 7. What's the square root of 7 times the square root of 7? No, it doesn't just disappear. No, it's not just the square root of 7. No, you shouldn't write down the square root of 49. It is the square root of 49, but that's 7. So we get 3 radical 7 over 7. Cotangent of theta equals 3 square root 7 over 7. Next we have secant theta. Secant theta is the reciprocal of which trig function? Which of the three basics is reciprocals with secant? Cosine. That means secant is hypotenuse over adjacent. You can get this answer from the picture, or you can get this answer by finding the reciprocal of cosine. The benefit of going back to the picture to get your answer is if you made a mistake here, at least you won't get 2 questions wrong because of it. What is the hypotenuse over adjacent? 8 over 6, which reduces to 4 over 3. Do we need to rationalize this? No. It already is simplified. 8 over 6, I wrote 4 over 3. So final answer, secant of theta is equal to 4 over 3. Again, definitely avoid slanted fraction bars. Have a clear numerator and a clear denominator. You don't want to wonder if something is in the numerator or denominator. Cosecant. Cosecant's the only one left. Which trig function is this reciprocals with? Sine. So that makes this one hypotenuse over opposite. Now, instead of doing this one from the simplified form, which I easily could do, I'm actually going to do it from the original picture, just so I could add a little bit extra work for simplifying to point out to you guys. The hypotenuse is 8, and the opposite side is 2 square root 7. Now, while I can reduce it, sometimes I'll have a denominator that looks like this that won't reduce. When you need to rationalize a denominator like this, you multiply on top and bottom by the same thing. You still need to multiply by 1. I'm going to multiply on top and bottom by just the square root of 7. I really don't need the 2. 8 times the square root of 7 is 8 square root 7. Square root 7 times square root 7, as we did before, is 7. 7 times 2 is 14. Now I'll reduce. 8 and 14 are both even numbers, so we can definitely reduce a 2 from both the numerator and denominator. Cosecant theta will equal 4 square root 7 over 7. And I just did what I told you guys not to, so I'm going to rewrite it. 4 square root 7 over 7. I'm guilty too. Let's cross that out. Bad. I think it's important that you make a conscious effort to look back at how we rationalize these denominators when you have to do one in the future. I also think it would be important for you to check out your notes and make sure you wrote down everything when it comes to simplifying radicals. People tend to forget how to do these things or are overconfident and think they already know how and make lots of mistakes when they're doing problems on their own. I wouldn't want that to happen to you, so please reference this example and the other example when you're doing practice problems on your own. Okay, so what we have here for example 3 is a triangle with none of its sides labeled. We know we have a 30-degree angle, and we want to find the sine, cosine, tangent, cosecant, secant, cotangent of theta, given that theta is 30 degrees. What else can we add to this drawing or diagram to give it some more detail? One thing we can add is we know that that has to be a 60-degree angle. Now that we see 30, 60, 90 all sort of laid out for us, we can also remember that we learned special right triangles, and we should know the expressions that we can use to represent each side. Do you remember how long this side should be? This side should be x. This side, if that's x, is how long? If you said x square root 3, you are correct. And then what's the length of the missing side? The hypotenuse would be 2x. Now, we don't need to have actual measurements. If you wanted to make them up, you could, but that's sort of a silly step that's going to be inefficient. We can use the sides with x in them because the x is going to reduce anyway. It's sort of like the common factor among all the sides. Now, what ratio is sine? Sine is opposite over hypotenuse. Opposite of 30. The side opposite of 30 is x. What's the hypotenuse? 2x. How does x over 2x reduce? X over 2x reduces to 1/2. So that's really something that you should and could have memorized. The sine of 30 degrees equals 1/2. Sine of 30 degrees equals 1/2. Next, cosine of 30 degrees. Cosine is adjacent over hypotenuse. What am I going to fill in for adjacent and for the hypotenuse? I'll have x square root 3 over 2x. Those x's will still reduce. We'll have square root of 3 over 2. That's another fact that you can have memorized. It's always true. The cosine of 30 equals square root of 3 over 2. Tangent. Tangent of 30. Opposite over adjacent. The opposite over adjacent will be x over x square root 3. Here we have a little bit more work cut out for us. That leaves us with a 1 over square root 3. This needs to be rationalized. 1 over square root of 3 will get multiplied on top and bottom by square root of 3, and that gives you square root of 3 over 3. My dog is in a barking kind of mood. Apologies. So, conclusion, tan, or tangent of 30 degrees equals square root 3 over 3. I actually just remembered I forgot to highlight those answers from earlier. Now, we are left with the 3 reciprocal functions. I'm going to do this the short way. Since we know that these answers are all correct, we can just use the reciprocals to finish up. Cosecant is the reciprocal of sine. I have them in order and I color coordinated. The reciprocal of 1/2 is 2. You don't need to write 2 over 1. Secant of theta. That's going to be the reciprocal of cosine. 2 over the square root of 3. Take a second and try to rationalize this in your head before doing it on paper. You should end up getting much better at rationalizing things in your head. Cotangent. I'm going to have the reciprocal of tangent, but I'm not going to go to my rationalized answer. Instead, I'm going to go to the answer before I rationalized it, 1 over the square root of 3. Now, when I find the reciprocal, it's just square root of 3, and it doesn't need to be rationalized. This is a super important trick that one too many people don't take advantage of. Next, we have example 4. Now, here, we don't have any angles labeled or sides. Well, that's not really true, is it? We have the fact that we have a right angle, and these two sides are equivalent. That means that these two angles are also congruent. What kind of triangle are we working with then? We're working with the 45, 45, 90 triangle. We're going to treat this one just like we did the 30, 60, 90, and we're going to label the expressions we learned when we learned our special right triangles. X, and x root 2. Sine of theta, whether we look at this angle or this one, we'll get the same thing, is the opposite over hypotenuse. Well, that's x over x root 2. The x's will reduce, but we still need to multiply on top and bottom by square root 2 because we need to rationalize. While the x's go away, 1 times square root 2 is square root 2, and root 2 times root 2 is 2. So the sine of 45 degrees is radical 2 over 2. Cosine is adjacent over hypotenuse. I want you to look at this picture and think about that. What do you think cosine will be? Cosine of theta will be root 2 over 2 as well. Give that some thought. Now for tangent. Tangent is opposite over adjacent. What do you think tangent is? Tangent is 1, because anything over itself is 1. The reciprocals of cosecant and secant will also be the same since sine and cosine are the same. They'll be the same as each other, not the same as sine and cosine. What's the reciprocal of root 2 over 2? Well, let's go back. Before we rationalized it, it was really 1 over root 2. What's the reciprocal of 1 over root 2? Root 2. That means secant will also be root 2. Give that a little bit of thought if you don't understand. What's the reciprocal of 1? The reciprocal of 1 is still 1. All of this is actually really important information that you're going to end up memorizing over time in Algebra 2 and in pre-calculus. You'll definitely have it memorized if you plan on taking calc. So if you like to get ahead of the group, it might not be a bad idea to memorize it now. I'm going to rewrite these all on the next page so that we can have a nice organized list. But before we go on, let's take a second to talk about something here. Anytime we need the reciprocal of, say, the square root of smiley face, is, sure, you can say it's 1 over the square root of smiley face. But that's ridiculous. After you rationalize, it'll always be square root smiley face over smiley face. So it's definitely a good thing to know that the square root of something is going to be reciprocals with the square root of that thing over that thing, and vice versa. So what's the reciprocal of radical 5? Radical 5 over 5. What's the reciprocal of radical 7 over 7? Radical 7. How do you rationalize 1 over radical 11? Radical 11 over 11. This is just a big time saver. Now here is a quick list reiterating what we just did on the previous page. Sine of 30 is a half, cosine of 30 is root 3 over 2, tangent of 30 is root 3 over 3, cosecant of 30 degrees is 2, because it's the reciprocal of sine. Secant of 30 is 2 square root 3 over 3, because it's the reciprocal of cosine. And cotangent of 30 is square root 3, because it's the reciprocal of tangent. And this is the example I kind of referenced with that little smiley face example. So are these. Sine of 45 is square root 2 over 2. Cosine of 45 degrees is also square root of 2 over 2. Tangent of 45 degrees is anything over itself, essentially, because it's an isosceles triangle, so we get 1. Cosecant of 45 is square root 2, because it's the reciprocal of sine. Secant of 45 is also square root of 2. Being that it's an isosceles triangle, we are seeing the same answers here. And cotangent of 45 is also 1. Now, there is one other thing I want to add on to this. The sine of 30 is equal to the co-function of the complement. What's the co-function of sine? What's the complement of 30? The sine of 30 and the cosine of 60 are equal. They're both 1/2. The trig of an angle is equal to the co-function of the complement. What's cosine of 30's co-function? Co-function of cosine is sine. What's the complement of 30? 60. Going down this side will always be 60 degrees because that's the complement of 30. What's the co-function of tangent? Cotangent. All you need to do to find the co-function is either put the co-word in front of the function or take it away. Sine, co-function is cosine. Cosine, co-function is sine. What's the co-function of cosecant? It's secant. And the complement of 30 is 60. All we're doing is making a list of facts that would really be useful for you to have memorized. Secant of 30 degrees, what's the co-function of secant? Cosecant. CSC is the abbreviation for cosecant. And what is the complement of 30? Again, it's 60. We said everything will be 60. Last, what will I put here? Tan 60. There's no reason for me to do it here because what's the co-function of sine? Cosine. What's the complement of 45? 45. So this one is already built into itself. So this is a great list for you to memorize, flashcard style, okay? So I would definitely recommend you spend some time and memorize these and long-term memory, okay? Memorize this for forever type of thing.